All right, so I think we're being recorded now. So there's a couple things I want to go over initially. First off, the college has approved us to do our in-person labs, which are scheduled for the 17th and 24th. I am looking at our lab schedule thing. I'm going to post a link to it in the chat. So, and it looks like 8 people have signed up for the 17th and 5 for the 24th. So the 17th is our additional, or the 17th is our normally scheduled lab class. That is when the course description said that we were going to have a lab. So hopefully we're at least available that time. And then the second date was chosen based off of that initial survey I sent to you all at the beginning of the semester. So please sign up for one of these. I sent out an email that has some of the rules and procedures as far as attending these labs. You have to wear a face covering at all times. You have to maintain social distancing unless if it's absolutely necessary. You know, if there's like a first aid situation, unless if you live in the same household, you can't carpool. And does anybody know if Cabrillo is enforcing parking these days?
They're not enforcing it.
There's no,
Okay.
yeah. And even if they were on Saturdays, it's open for the farmers market. So there's no enforcement on Saturdays anyway.
Okay. Excellent. So what we're probably going to be doing is we're going to meet down at the sports fields right next to the stadium. I think it sounds like we'll be able to use one of those on both Saturdays. If not, we'll just walk back up to another location on the other side of Soquel and we'll figure it out. But for now, plan on meeting down at the sports fields. I will be there early, setting up equipment. I'm not allowed to get help from anyone doing that. So that's a little inconvenient, but it'll be fine. And what we're going to be doing essentially on that day is the theodolite angles about a point lab, except for we're all going to be, everyone's going to have their own total station, and then we'll kind of do it all together. We'll be set up at different points. I'll lay out some tacks and a really very large triangle, and we'll all cite them in. So we're going to do our best. I've never done a simultaneous social distance lab before, so we'll figure it out. Hopefully there aren't too many snafus. And then we'll also be doing a lab where we find the height of some structure, and we'll find the height using some geometry. So that'll be fun.
I'm sorry, what time are we meeting? And I don't really know where the sports fields are. Are they on the opposite side from the actual college?
Yeah, they're on the, oh man, this messes me up because we're on a bay. But yeah, they're on the
south side of the campus.
South side, thank you.
And what time? 10?
9 to 3 p.m.
9 to 3, okay.
Yeah. So I'll send out a little Google Doc. I'll have a picture of the location and all that jazz of where we should meet. If for any reason any of the reasons that were listed, like you have been in contact with somebody that has been diagnosed with COVID, you meet any of the criteria for, that I sent out a list, chills, fever, etc., stuff like that. If you have any of those things outside the normal, please just don't attend. Just say, hey, I need to do an at-home lab. But otherwise, attending one of these 2 lab sessions is required. So any questions on that? One thing to note in the email that I sent you, there should be a link to like a CDC, coronavirus check. If you click on the link and then on the right hand side of the page, there's a coronavirus self-checker. Please fill that out beforehand, and you can do it like on your phone. And if you could just take like a screenshot, or if you do it on your computer, take like a screen grab and just send me a picture of that. So that way I have everything on file in case if anyone gets on my case. Sound good? If you have any,
Yeah.
if you have any issues, just stick around afterwards and let me know. Anything else? Oh, okay, so that was that. And then the other thing was that I sent out a survey, just kind of getting a gauge of where people are at. Seems like for the most part, things are okay. I think that the biggest request for people outside of why can't we just go back to campus, which I am not in control of, is maybe some more calculations, some more example calcs, so we can definitely work that in. And then some people had some really good suggestions about like just general videography. So that was really helpful. You know, I'm not a videographer, so just kind of tips about how to do things there are really helpful. One thing that is unfortunately a problem with these eyepieces is that if you've ever tried to take a picture or a video through an eyepiece, it is really hard. And these instruments, they have a really narrow angle of view. So, and a lot of times these eyepieces are actually kind of set back. So I can't actually get a camera or my phone within that angle of view to look at like the crosshairs and whatnot. So I will source some examples from the manufacturer and include those going forward. So yeah, thanks everyone for all the suggestions. They're great. Cool. Without further ado, let's go through some of the measurements for Lab 4. Let me start my screen sharing. Awesome. So let me get rid of some of the stuff. So here's our field book. Please set up your field book like this, where on the left-hand side we have measurements, and then on the right-hand side is the details. We can, any calculations can kind of go along the bottom of the page in general. If we have some calcs here, as we saw last week, if we need a little bit of space underneath, we could do some calcs over here. Please don't forget your name and your signature, as well as the required description and all of that. So that is actually worth I think it adds up to be about 3 or 4 points. So 30 or 40% of your lab notebook grade is literally filling in the description, writing the title, writing your name, writing your signature, and so yeah, just make sure you do those things. Get those easy points. Cool. So theodolite angle is about a point. this will be what we're going to be doing a very similar lab to this next week, for the most part, because it really cuts down on the amount of time that you have to set up. As you watch the videos, I'm sure, like, as you can kind of tell, it's a tedious process to actually set up your equipment over a specific point. And since I'm the one setting up like 6 total stations, I just don't want to deal with that. So we're going to do this version. This way, in Lab 4, we just set up and level our equipment on the inside of a triangle. So we're going to be using the exact same triangle from Labs 2 and 3. Remember that triangle is on the southwest lawn in front of the Cabrillo Library. So please utilize Google Earth to get an idea of like where some sidewalks are and include those in your sketch. All right, so we already went through in the intro setup thing how to set up the lab notebook, where our monument is, or in this case, our monument is our instrument. That's at this point X on the interior of triangle ABC. And we're just going to be turning 3 angles. We're going to be going A to B, B to C, and C to A. And if we go a full circle, the sum of the angles should be 360 degrees. So we're going to do that, but the way that we do that with a theodolite is by turning double angles. And similarly, we're going to be doing that on a total station. A theodolite, those double angles are taken manually by going through the locking and unlocking procedure. Whereas on the total station, we're going to be able to just tap a button and it's going to digitally lock in the angle. So it's a little bit more straightforward, but it's a very similar idea that we turn one angle, we lock in that measurement, we go back to the beginning, and we turn it again. Did that make sense to everyone? To some degree, the lock, unlock, or would it be? Does anybody want to?
For the most part. So basically, I understood that if you want to keep your top measurement, you move the bottom. And if you don't want to and you want to reset, you move the top. And then that made sense for going back doing the double
Yep.
angles.
Yeah, that is the main takeaway here, is that your top plate is what you move in order to take a measurement, and your bottom plate is what you move if you want to adjust the site.
Right.
That's the takeaway. All right, so let's move on to our next point in this lab notebook, which is monument X, citing point C, and we're going to cite point C twice. So we're still here at our same monument, we're not moving, but now we're going to cite B, and then we're going to turn an angle to C. We're going to lock the top plate, come back, cite B again, unlock the top plate, turn our double angle. So we set our initial angular measurement to 0. You don't have to, you don't absolutely have to. You could start at any angle you want. You just have to correct for that difference. So why not just start off at 0? It makes things easier. So we cite B, and we're literally putting our crosshairs on that pin. And this one's fun, especially if it ends up being a really hot day and you're like sighting in over some asphalt. It's actually hard to do because you get those heat waves. and it's actually kind of hard to get a good measurement. So, all right. So we turn an angle, and that angle is 163 degrees, 12 minutes, and 13 seconds. All right. What should we do now? If we turned that first angle B to C, how do we get back to B?
Lock the top plate, unlock the bottom plate, turn back to B.
Exactly. And with the total stations, it's just all digital. So you do what you said, Olga. We get back to B, and we turn again to C by unlocking the top plate. So that measurement is 326 degrees. 25, oops, not degrees. So I'll just draw a line through that. Minutes. And 28 seconds. So if that is our double angle, can someone punch into their calculator what our average angle is? So would it be helpful for me to go through the math of doing a calculation on a degrees, minutes, seconds measurement? I know it can be a little confusing, right? Because now we're working in base 60 rather than base 10, base 6. I don't know, I'm not a mathematician, but I can do the math. So let's just do that. Let's just go through a little bit of math here. So what was the angular measurement?
163 degrees, 12 minutes, and 13 seconds.
The double angle. So the double angle was 326, 25, 28.
Right, yeah, my bad.
No worries. It was 25, 28. All right. So unless if you have a calculator that does degrees, minutes, seconds for you, this is how, I'm just using like a TI 30X, the old school TI, so it doesn't have that function. So let's just go through the math of how you could do this. So for me personally, I like to convert this to a decimal. So in decimals, 326. Wow, I keep messing up numbers today. 326 degrees plus 25 minutes, and there are 60 minutes per 1 degree, plus 28 seconds, and 1 degree has 3600 seconds. So what is our angular measurement in decimals? Okay, so we're getting a couple different answers here. Someone's getting the decimals 0.4178 and somebody else is 547. Yeah, so I'm getting what Elan is getting. So remember, if you do this in your calculator, let's do, in your calculator, how you would write this, you could either do it as multiple lines or you could do it as a single line. If you do it as a single line, it's going to look, the syntax is going to look something like this. 326 plus 25 divided by 60. Make sure you use those parentheses. Okay, cool. Everyone's getting it the second time. Oh, what? Oh, my calculator does have the DMS. Wow, that's amazing. Anyways, let's just go through the math. I think it's worth thinking about at least. Plus 28 divided by 3600, again, in parentheses. Wow, I've gone all these years just doing it this way. This is a revelation. So, great. Then you just divide that by 2, and then you can just whack the degrees, minutes, seconds. Oh, it's a little, yeah. So that's how you get the number 326.4244. When you're doing the math, it's good to keep 4 decimal places. Now, average angle is just equal to 326.4244 over 2. And then you do the reverse operation in order to get the minutes and seconds back out. Does that make some sense? No sense?
That makes a lot of sense.
Great.
For me at least.
So yeah, 163.2122, which if we put it into degrees, minutes, seconds, that 0.2122 I can't get my degrees, minutes, seconds thing to work. But anyways, you just go backwards now, and now you would say 0.2122 degrees, 1 degree, 60 seconds. $12.732 minutes. Sorry, I said seconds before. And that 0.732 minutes, 60 seconds per minute. $43.9, so 44. So our average angle is 163 degrees, 12 minutes, 44 seconds. Or you could be a smart person and use your calculator. 163, 12, 44. So I'm needing a little bit more space here, so I'll just put a little dividing line. 163 degrees, 12 minutes, and 44 seconds. And this particular instrument is accurate to, well, people have various opinions, but this instrument is accurate to 20 seconds. So 163 degrees, 12 minutes, and 40 seconds would be our reported average angle. So one thing to keep in mind is that we're going to be using these average angles that we calculate in our calculations. You don't want to use rounded numbers in your math. The rounded numbers are just what you're reporting. You want to use all of the digits in your mathematical operation. All right, so now that's a angle BC. We're still at the same point X. Remember, we're just in the center of this triangle. And now we're going to do C to A. So we're going to cite C and go to A. By going to C, we're going to do ourselves a favor, and we're going to dial our measurement in to 0. And then we're going to turn to A, get 40 degrees, 20 minutes, and 20 seconds. And as we all kind of understand now, we lock that top plate on that measurement, unlock the bottom, turn back to C, lock the bottom plate, unlock the top plate, and turn back to A. And when we did that, our double angle measurement is 80 degrees, 41 minutes, and 45 seconds. So can someone type into the chat what that average angle is? 40.3479. And what is that in degrees, minutes, seconds? 40, 20, 53. Do we have somebody to second that? Always good to check each other's math. Awesome. Always good to double check the math. I forget the exact saying, but if anyone knows about the Millennium Tower in San Francisco, it's a really big deal because it's sinking. So somebody messed up the engineering site investigation. Well, they messed up a lot of things. They basically made the point that you have to have two people, two independent sets of people do two things wrong twice for something in engineering to go wrong. So it's always good, even for simple calculations, to double check the math. And if we want to report that as our average rounded angle, we're at 53 minutes. So that's going to round up to the next, or excuse me, 53 seconds, which is going to round up to 60 seconds, which puts us at 40 degrees, 21 minutes, and 0 seconds. All right, so let's check our error on this loop. So it should be 360 degrees, but let's do the math first. And one of the things I noticed on lab 3 is that there are some errors in doing the degrees, minutes, seconds math. So let's just make sure we walk through that and really, really make it clear about how we're carrying. So it's the exact same idea as doing regular addition, where you have to carry to the next decimal place, except for now we're carrying seconds to minutes and then minutes to degrees. So one way of doing this that I find useful is, rather than carrying at the beginning, and you don't have to do it this way, this is just kind of one alternative approach, is that rather than trying to do all the carrying at once, you're going to add up all of the seconds, all of the minutes, and all of the degrees. So let's do it that way. So by doing that, what we would be doing is we're going to be adding the degrees, minutes, and seconds from our average angle column. So let's do that in our calculation line. Let's draw a line here. And let's draw our summation symbol. And let's just make this really, really clear where all of these numbers are going. So let's add up the seconds. So that would be 25 seconds plus 44 seconds plus 53 seconds. So that's 122 seconds. Let's add up the minutes. And again, if this doesn't mentally work for you, let's go through it another way. This is how I like to do it. 32 plus 12 plus 20. 64. Oh, I messed up. I keep using the wrong symbols today, everyone. I really apologize for that. So 64 minutes, 122 seconds. Now let's add up the degrees. 157 plus 163 plus 40. That is 360. All right. So what I like to do now, it makes it a lot easier to do all of the carrying. So 122 seconds. If you just divide that, if you put 60 into that, that's just 2 minutes. So that means that we have to carry over 2 minutes. So we're getting 66 minutes, 2 seconds, 360 degrees. And similarly, 66 seconds is 1 degree. Gosh darn it, it's the seconds again. I'm really messing that up. 66 minutes is 1 degree and 6 minutes. So that carries over 360 degrees, 6. Oh, nope.
361.
361. Thank you. My brain is just not firing. 6 and 2 seconds. So that is one way that you can go through the math to make sure that you're carrying over. Yeah, thank you, Kenny, for the confirmation there. You're carrying all of your degrees, minutes, and seconds correctly. It's a different mental base system. We're all used to base 10, so it's a little, you just have to get used to it. And this method works for me. Others work for other people. Let's chat about it. So 361 degrees, 6 minutes, 2 seconds, minus 360. So that makes the math pretty easy there. Our error is 1 degree, 6 minutes, and 2 seconds. So that's
I'm sorry. What error are we allowed in this lab? Or
so
like
for this lab, we don't have any allowed error. And in this lab in general, since you aren't actually doing the measurements, I'm not going to mark you off if I do give you data that has an unacceptable error in it. So the point of this lab is just to get used to turning our angles. It'll be the same thing in person. The point of meeting in person is that we get familiar with the equipment, not whether or not you can measure something down to 1 second. It's fun to try and like get as close as you can, but that's not really the point of what we're going to be doing in lab for this upcoming lab at least. So even though for this specific lab there isn't a specified error, generally what we use in this lab is 1 minute and the square root of n seconds. So the square root of n is 3, right? Because we have 3 turns. So this is kind of for fun, right? I don't know why I have 144 written down, but so generally it would be 1 minute. Oh, it's 1 minute times the square root of n. So and n is equal to 3 in this case. So what would that be in minutes and seconds? So the square root of n is equal to that's 1 minute times the square root of 3. So that's 1.7321, which is equal to 1.7321 minutes. And what is that in terms of minutes and seconds? $1.44. So we did not do great. By we, I mean me, because this is my old lab data. So I think that when we did this, we did not understand how leveling worked, that you had to level both the big bubble and then the central bubble. I think that we really, really messed up that aspect. And that's why we were so far off. But like I said, the point of this lab is just to get used to the equipment. All right, so that is it for the interior angle lab. There are no additional calculations that need to be done. Let me check. Yeah, so that's it. There's no additional calculations. You know, you can imagine that we could distribute this error based on the size of the angle, but we're not going to do that in this lab. So just remember, for lab 4, we've already done everything that we need to do in terms of calculations. Just make sure you add the description, you know, all of the required components here, all of the required components here, your signature, and many of you did this, but just make sure that you add a couple more details about this triangle ABC, maybe some walkways, maybe some grass. It doesn't need to be an artistic masterpiece, but straight lines and neat handwriting are what we're looking for. All right, that's it for lab 4. So I'm going to stop the recording so we can have these as 2 separate chunks. I think if I push stop and then I can restart later, it'll be another one. So yeah, let's take a yeah.